Okay, folks, how we doing today? We're going to talk about solving absolute value equations. Or when you're done watching this video, you should be able to explain what an absolute value number or expression is. You should be able to solve absolute value equations. You should be able to explain what an extraneous solution is. You should check for extraneous solutions when you're solving an absolute value equation. And then you should be able to solve an absolute value equation by graphing. So let's go ahead and get started. First, what's an absolute value? Most of you probably remember that the absolute value of a number is always positive. What I want you to remember is that the absolute value of a number is the distance between that number and zero on a number line. Distances are always positive, and that's why it's going to be a positive number always. What's the absolute value of 3? Well, if you think about it, how far away is 3 away from 0? It's 3 spots. And so the absolute value of 3 is going to be 3. What's the absolute value of negative 5? It's not that it's the opposite of 5. It's that negative 5 is 5 spots away from 0. So that's why the absolute value of negative 5 is equal to 5. Okay, so take a look at A1, A2, and A3 and see if you can come up with what x is equal to based on what we just talked about. Find the absolute value of negative 7, 7, and negative 4. Pause the video and then start back up again when you're ready. Okay, awesome. Hopefully you did that. Hopefully you found out that the absolute value of negative 7 is going to be 7 because negative 7 is 7 away from 0. The absolute value of 7 is also going to be 7 because it's 7 away from 0. And the absolute value of negative 4, that's going to be 4 because it's 4 away from 0. So what does this mean? This is different than what we just talked about because it's got a variable inside the absolute value bar. And basically what we know is that x has a distance of 4 from 0. And what we want to do is we want to find any x's that are 4 steps away from 0. Well, if you think about it, 4 is clearly 4 steps away from 0. So if I plugged an x in here, it would be the absolute value of 4 is equal to 4, and that would be correct. Absolute value of 4 is 4, so that is one of our solutions. Or any other numbers that are 4 away from 0. Well, in fact, negative 4 is also 4 away from 0. So both 4 and negative 4, if I substitute them back into this original equation, will make it true. So they are both solutions. So once you go ahead and try A5 and A6, pause the video and use what we just talked about and see if you can come up with the answers for these. And then start back up again and we'll compare. Okay, thanks for doing that. So what numbers are 7 away from 0? Well, 7 and negative 7 are 7 away from 0. And what numbers are negative 4 away from 0? Well, think about it. There are no numbers that are negative. Distances have to be positive. There are no numbers that are negative 4 away from a number. So this is going to be no solution. There are no numbers I can substitute in for x and then take the absolute value of it and have it equal to a negative number. So we would say either the words no solution, or you could use this empty set notation, the null set, the 0 with a line through it. Any of those things will work in this situation, but the answer is not 0. The answer is no solution. The steps for solving an absolute value equation are the same for each one, and all you got to do is write these down and try to remember them. The first thing we're going to do is we're going to isolate the absolute value, and once we get the absolute value by itself, then if it's equal to a negative number, we're going to stop, because then the answer is going to be no solution. The second step is we're going to rewrite the absolute value equation as 2 separate equations without the absolute value bars. One is going to look exactly like the original, and the other one, we're going to take the other side, the non-absolute value side, and we're going to multiply it by negative 1. And then we're going to solve both of those equations. And the very last step is that we're going to check by taking our answers and substituting them back into the original equation. We have to make sure they're not extraneous. Now, hopefully you've heard this word extraneous solutions before, but let's talk quickly about what that means. And what I want to do is basically start by talking about what it means to solve an equation. What's the solution to this equation? Well, I'm going to tell you the solution is 3. And what I want to know is, how do you know that it's the solution to this equation? And see, the answer isn't, well, because I took away 1, and so then that became a 9, and then I divided by 3, and 9 divided by 3 equals 3. That's how we found the solution. The reason that 3 is a solution is because it's the only number that I can plug in place of x that's going to make this equation true. If I put a 3 in place of x, it's going to be 3 times 3, or 9, and 9 plus 1 does equal 10. This is a solution to this equation because it makes the original equation true. So whenever you're solving an equation, you're trying to find the number or numbers that make the equation true. Now, extraneous solution. When you follow the steps or the process for solving the equation completely correctly, and sometimes, however, it generates an extraneous solution. And there's lots of different ways that this can happen. One of them is squaring both sides. And in this case, like I said, when we follow these steps for solving an absolute value equation, most of the time, a lot of the time, what's going to happen is we're going to get good, valid solutions. However, there are going to be some times where we do exactly these steps and the answer is going to be extraneous, which means it's not going to make the original equation true. So checking your answer when you're solving an equation by plugging it back into the original is always a good idea when you're solving equations. However, when we're talking about absolute value equations, it's really something that you should do. It's a requirement. So let's take a look at this. We're going to do this one together. This is the absolute value of a plus 1 is equal to 8. And what we want to do is we want to figure out what a is. And if you recall, the first step is to get the absolute value by itself. Now, the absolute value is by itself. There is only absolute value on this side of the equation. Now, I know there's stuff inside the absolute value, but you're not worried about that just yet. The first step is to get the absolute value by itself. So that's done. The next thing is, take a look. Is the absolute value equal to a negative number? No, it's not. Now, if this was equal to negative 8, we could stop and say that there was no solution because there's no absolute value that's going to equal a negative number. But that's not our situation here. So then the next step is we're going to rewrite this as two equations. You'll notice there's no absolute value bars, and this first one looks exactly like the original, only it doesn't have absolute value bars. The second one looks like the first one, where you'll notice we've just rewritten what's in the absolute value. The only difference is I've taken 8 and multiplied it by negative 1. I've got two equations now, and all I got to do is go to step 3 and solve both of those. In this case, they're pretty simple. I'm going to subtract 1 on both sides, and I'm going to find out that the answer is going to be 7 or negative 9. So now the last step is I'm going to take both of these answers and I'm going to substitute them into the original equation. Here's my 7. If I place the a with a 7, it's going to say 7 plus 1. Well, the absolute value of 8 is 8, so this one checks out. And then if I take a negative 9 plus 1, that's going to equal negative 8. Now keep in mind, though, it's the absolute value of negative 8, and the absolute value of negative 8 is 8, so this also checks out. Those are both valid solutions. So what I want you to do now is I want you to take a look at this one. It's very similar to the one we just did. I want you to try doing it on your own. Pause the video, try doing this one, and then start back up again and we compare our work. Awesome, hopefully you did that. So we've got g minus 3 is inside the absolute value, but the only thing is the absolute value, so it's isolated. So then we're going to rewrite it as two equations. G minus 3 is equal to 10, or G minus 3 is equal to negative 10. And then to solve this, what we're going to do is add 3 to both sides, and we're going to find out that G is equal to 13, or G is equal to negative 7. The last step is we plug our answers back into the original equation, and they both check out. 13 minus 3 is equal to 10, and the absolute value of 10 is still 10. And negative 7 minus 3 is negative 10, but the absolute value of negative 10 is 10, so 10 does equal 10. Both these answers check out. All right, so now take a look at this. Can you try to do this one? Well, that's a little bit of a trick because you'll notice the absolute value is by itself and it's equal to a negative number. In this situation, you just stop and you write the words no solution. Think about it. What if n equals negative 10? Well, that would be 5 times negative 10 or negative 50, but the absolute value of negative 50 is going to be 50. What if I put a positive 10 in there? It's going to be positive 50, and the absolute value of 50 is going to be 50. It's never ever going to equal a negative number because whatever n is, what I'm going to do is the last step is take the absolute value of it. So when you see the absolute value by itself and it's equal to a negative number, just stop. That's it. You got to write the answer is no solution. And we can write that a couple different ways. Here we can write it as the words no solution, or we could write empty set or the null set. So what's different about these two equations? They're still absolute value equations because they've got a variable inside the absolute value, but the absolute value has not been isolated. So what we've got to do now is we're going to have to use opposite operations in order to get the absolute value by itself. In this regard, it's kind of similar to solving an equation and getting x by itself, but in this case, we're getting the absolute value by itself. So we're not going to change what's inside the absolute value bars. We're just going to get it by itself. So let's take a look at the first one. 2 times the absolute value of x plus 6. How do I get rid of the 2? Well, what's the opposite of multiplying by 2? It's dividing by 2. So if I divide both sides by 2, this is going to be a 1, this is going to be a 9. I'm going to end up with the absolute value of x plus 6 is equal to 9. Now the absolute value is by itself. It's not equal to a negative number, so I go to the next step and I'm going to rewrite this as two separate equations. One of them is going to be x plus 6 is equal to 9, and the other one is going to be x plus 6, but it's going to equal negative 9. So again, you'll notice the first parts of these are both the same. All I'm going to do is take one of them and multiply the other side, the non-absolute value side, by negative 1. So now all I got to do is solve these by subtracting 6 on both sides. And I'm going to find out that my answer is 3 and negative 15. And then when I plug them back into the original, they both check out, and that makes me very happy. Take a look now at this one. Why is this absolute value not by itself? Well, this 7 is in the way. This 7 is not here. It's a negative 7. So what's the opposite of minusing 7? Well, it's adding 7. So if I add 7 to both sides, this is going to become a 0, and this is going to become a 10. And so now I've got 4s, or the absolute value of 4s minus 8 is equal to 10. And the absolute value is by itself. This is not a negative number. I'm going to rewrite it now as two separate equations. One's going to be 4s minus 8 equal 10, and the other is going to be 4s minus 8 equal negative 10. And now all I got to do is solve both of those by adding 8 to both sides. I'm going to find that 4s is equal to 18, or 4s is equal to negative 2. I'm going to divide both of these by 4, and I'm going to find that s is equal to 9 over 2, or negative 1 over 2. And then to check to see if either of these answers are extraneous, I'm going to plug them back into the original equation, and I'm going to find out that they both check out. It makes me very happy. Both of my solutions are valid, so neither of these are extraneous. They both make the original equation true. So let's take a look at this one. Once again, the absolute value is not by itself. So what we're going to do is we are going to subtract 6 on both sides to get the absolute value by itself. And when we do that, it's going to say the absolute value of 3d minus 9 is equal to negative 6. Now, the absolute value is by itself, and then we ask ourselves, is this equal to a negative number? And it is. And is absolute value ever going to equal a negative number? No. And I can stop right now, and I can write down that these are no solution. Now, what if we had done this? What if I had gone ahead, the absolute value is by itself, I rewrite it as two separate equations, 3d minus 9 equals negative 6, notice how it looks exactly like the original, and then 3d minus 9 is equal to positive 6, because I've multiplied that by negative 1, and now when I add 9 to both sides, I end up with 3d equal 3 and 3d equal 15, and it appears like my answers are 1 and 5. However, when I plug both of these back in, 3 times 1 is 3. 3 minus 9 is negative 6. What's the absolute value of negative 6? It's 6. not negative 6. So this does not check out. Negative 1 does not make my original equation true. And if I plug in a 5, it'll be 3 times 5 or 15, and 15 minus 9 is going to equal 6. But the absolute value of 6 does not equal negative 6. So then I know that neither of these answers are correct. So they're both extraneous. What about this? In this one, I've got the absolute value, but and it's by itself. That's awesome. And there's more than one thing over here. So in this kind of case, if there's a variable, we're not sure if it's negative or not, so we're going to keep on going. So the first thing is the absolute value by itself? Yes. So we'll rewrite this as two separate equations. One is 2m minus 3 equals m plus 4. Once again, you'll notice it looks exactly the same, only it doesn't have absolute value bars. The other one is going to start out the same, 2m minus 3, but then I'm going to multiply this entire thing by negative 1. So it just isn't going to be negative m, it's going to be negative 4. Both of these, it's like distribute the negative 1 to both of these guys. Anyway, now I've got my two equations, and all I've got to do is get the variable on the same side. So in this case, I'm going to subtract m from both sides. In this case, I'm going to add m to both sides. I'm going to end up with m is equal to 7. And I'm going to end up with 3m is equal to negative 1. And then when I divide both sides by 3, I end up with negative 1/3. So my two solutions are 7 and negative 1/3. And when I substitute them back in, they both check out. And so I feel good about those. Neither of them are extraneous. So why don't you try doing this one? The absolute value is by itself. So what I want you to do is go ahead and rewrite this as two separate equations. One just like the original, and the other one is going to multiply the 14 minus a by negative 1. And then go ahead and solve both those equations and start back up again. Okay, awesome. Hopefully you did that. So what we're looking at is a plus 5a is equal to positive or negative 14 minus a. So all we're going to do is multiply this side, the entire side, by negative 1. One of our equations is going to be 8 plus 5a equals 14 minus a. The other one is going to be 8 plus 5a, but then this whole thing is going to get multiplied by negative 1. And when I do that, this becomes a negative 14, this becomes a positive a. And now all I got to do is get a by itself. Well, why don't you go ahead and do that for both of these? Awesome, thank you for doing that. Hopefully you got a is equal to 1 and or a is equal to negative 5.5. And then of course when I check my solutions, I plug them back in and I find out that they both work. So in this equation, 2 times the absolute value of x plus 4 is equal to 6x minus 8. What we're going to do is we're going to subtract 4 on both sides. Negative 8 minus 4 is going to be negative 12. And then I'm going to divide both sides by 2 to get the absolute value by itself. And when I do that, I'm going to have x, or the absolute value of x. This divided by 2 is 3x, and negative 12 divided by 2 is negative 6. And I've got the absolute value by itself, and what I'm going to do is rewrite this as two separate equations. One is going to look exactly like the other, and the other one's going to be multiplied by negative 1. So the first one is going to be x is equal to 3x minus 6, and the other one is going to be x is equal to negative 3x plus 6. And all I've got to do now is solve both of these. Why don't you go ahead and try that and see what you get, and then start back up again when you're ready. Hopefully you got x is equal to 3 and x is equal to 3/2 or 1.5. And when I plug both of these in, what I'm going to find is that the 3, it's going to make the original equation true. However, the 3/2 or 1.5, well, the absolute value of 1.5 is 1.5, and 2 times 1.5 is 3, and 3 plus 4 is equal to 7. But 6 times 1.5 is equal to 9, and 9 minus 8 is equal to 1. 7 does not equal 1, That means that 3/2 or 1.5 is not a valid solution. We would say it's extraneous, and we would not list it as one of our solutions without calling it extraneous. In this case, we're going to say our answer is x equals 3. Now let's take a look at solving by using Desmos or graphing. We just found that the answer to this equation is x equals 3. So what we're going to do when we're solving graphing is basically we're going to graph each side of the equation and then find out where they intersect or are equal to each other. So let's take a look at that. I'm going to go to Desmos and I'm going to put y equals 2 absolute value of x plus 4. And the way you get the absolute value is, I suggest, by the way, you go to Desmos and try doing this with me. So if you go to the keyboard, you'll notice that there's an absolute value button right here, and so that's how you get the absolute value bars. And so the first side of the equation is going to be y equals 2 times the absolute value plus 4, and then the other is going to be y equals 6x minus 8. And see, once I've put each side of the equal sign into its separate line, then all I've got to do is find out where the graphs intersect. Now you'll notice this red one. That's the absolute value graph. It makes a V shape, and we're going to talk more about that in a later lesson. And then the other one's a linear equation, so it's going to make a straight line. And the way it's set right now, I can't see where they intersect. So what I'm going to do is I'm going to go over here to this minus sign, and it's going to zoom out. And when I do that, I'm going to be able to see, and sometimes you have to do more than once. In this case, I can see where they intersect. And once you see where they intersect, all you do is click on it, and then it'll tell you what the point is. Now keep in mind, we're trying to find x, and the point 310, the x is equal to 3. So the answer in this case is going to be 3, and you'll notice this line is never ever going to touch this other side. So there's clearly only one solution. There's only one point where these two graphs actually intersect or are equal to each other. Okay, so to go back to the regular viewing area, we're going to push this home button here. And to clear out our entries, just click that little X and that'll make both of these go away. And so now what I want you to do is I want you to go ahead and solve this one, B10. It's the absolute value of 2x minus 3. Now all you're going to do is you're going to put y equals the absolute value of 2x minus 3 on one line, and then y equals 5 on the other line. And then try to find out where they intersect. And those are going to be your answers, the x values. Why don't you pause the video and try that, and then start back up again when you're ready. Awesome. Hopefully you did that. It should look something like this. And you'll notice how we've got a line, and we've got this absolute value as a V shape. And there are two places where the two graphs intersect. And when you click on those, you're going to find out that the x is 4 or the x is -1, where these two graphs are intersecting. So the solutions to these two are going to be -1 or 4. These are the x values when the absolute value graph equals the graph of y equals 5. Okay, that's all I've got for you today. I appreciate you watching. I hope that helped.